who had missed the last session, everyone who watched the recording. Last session we discussed how to calculate all those using all those formulas, how to calculate the things like how to make the equation of simple linear regression, and then how to calculate this ANOVA table, all those things, SSE, SSR, SST, MSC, MSR, MST, all those things. Okay, so last session I assume that you will be knowing SSE, SSR, SST, MSC, MSR, MST, because this was in your BA1. This is from ANOVA table, so I didn't discuss in detail, so we'll be discussing that also. Some people are asking me to discuss. Okay, so today everyone is clear, right, about this how to calculate. You need to make the entire table to calculate all those things because it's step by step process. If you create this table in a graph paper while solving MCQ, then there will be no chance of doing mistakes. Okay, right. So now you can see this is one output, regression output, right? Are you familiar with this type of format?
Yeah, we have actually been following this format itself in the
Yes.
class.
Yeah. So this is how the format looks like, and how do we create this format? We'll be doing that using Excel also, using Art Studio also, and using SPSS also. I hope you all have installed, and you will have that data set I have said in the right. So this is the ANOVA table. We'll come to that first. This one because you all might be familiar with this. So this one is a regression. The first row itself represents the regression. The second one is the residual, the error thing, and the third column is the what the total. So first one we call SSR. So what is the full form of SSR? Anyone?
Regression sum of squares.
SSR. Oh, where is R and all? SSR. Sum square due to regression. Okay. Sum of square due to regression. SST is the sum of square, total sum of square, the last one, third column. SSE is sum square due to error, right? So be familiar with all these formulas. You need to be mug up all those to solve quick MCQs. Okay. So this is what SSR is. This is what SSE. This is what SST. So this is SSR, right? SSE, SST. So MSR, MSE, MST. So what is MSR, MSC, and MST?
Mean of squares, I guess.
Yes.
Mean of
Uh,
squares due to regression.
due to regression and mean of square due to error.
Due to
Uh,
error, sorry, MSE.
MSE, that one.
Mm-hmm.
MSR is the regression. Okay, you need to mug up all these formulas. The formulas are there in the PPT itself. This PDF only. You will have that PDF, right? If you don't have, you can check the WhatsApp group description. There is one drive link. You'll get all the PPTs.
Can you please zoom this Excel sheet?
Okay, yeah, I'll do that. Is it okay?
Yes.
Yeah. So this is what the F value is, and this is what the P value is. So if you know the F value, then you need to go to F table. You all remember, right? You need to go F table and you need to find the P value, and then assume alpha is equal to 0.05 or what to say? Uh,
0.025 and
yeah, the confidence interval, 95%
Hmm.
confidence interval.
Mhm.
So you need to identify whether the model is significant or not. Okay. So this is how you have to do that. This is what a simple format is, and then you remember a regression equation, right? I'll show you one more time the regression equation. This is a regression equation is y cap is equal to b naught plus b1 x, right? So b1 is the slope of the regression model, and b naught is the intercept, right? So when you know this coefficient value means what? Intercept, and this is what? Slope. Intercept means what? B naught. So this is the B naught value and this is B1 value. Okay. if you even know this b0 and b1, now if they ask you to calculate, to write the regression equation, now you can write the regression equation also, right? Clear, everyone?
Yes, sure.
Yeah. So this is what, uh, I'll go to the problem directly. So this will be the problem. In this first output, there will be some missing values. The red one actually the missing value, huh? So how do you identify these values? You will be given this value, and now you have to identify this value. How do you identify that? How do you find that value? Next, this value, how do you find? Yeah, we'll share the recording. So uh, this value will be given as blank, and you have to identify the value, and that will be 1 mark question for you. All those values uh, will be missing. The red one. How do you identify that? So you have all those formulas. Uh, should I feel I need to show how do I get all this first. Then I'll come to that. First, you have to understand what is multiplier and what is r square, what is adjusted r square, what is the meaning of that. Okay. So first I will show. Everyone can open the Excel sheet. Okay, this is what the Excel sheet is. First, you have to understand whenever you are doing regression with a data set. First, you have to understand which one is the dependent variable and which one is the independent variable. Here you can see, you can ignore this. Okay, ignore this column, is a serial number. So there will be always two variables, right? In simple linear regression, one will be dependent variable and another one will be independent variable. So here, what do you find? Which one will be your dependent variable and which one will be your independent variable?
Chance
GRE
of,
score will be the independent.
yeah, and chance of admission is dependent.
Dependent.
Yes. So chances of admission is dependent on GRE score. Your GRE score is, suppose the cutoff is 320. So uh, if there is a seat limit, suppose 100 seat and cutoff is 320 and exam is 360 marks. So though cutoff is 320, but if someone if someone is getting more than 320 marks, and the seat can be filled before reaching 320, right? Means someone is 100 seat is filled by 360 to 350 range. Okay. So the chances of admission will be increased if you get more marks, correct?
Yes, correct.
So chances of admission is dependent on GRE score. Clear, everyone? So this is a dependent variable, this is an independent variable. Okay. So everyone is having Excel in your system, right? MS Excel.
Yes, yes.
So this is my 2007 version. How many of you are using 2016 or uh, more than 2013 version?
I have 13.
Go to data tab then. Everyone. Just try. Go to data tab. Do we have this option? Just check it. Data analysis. Do you have that?
Which option?
Data analysis. This one.
Yeah, we have.
Everyone. Okay, if you don't have, if you are using 2007, I'll show you how to add it. So you can click here, you can go to Excel option. Okay, then you have adding. Then you can click on analysis toolpath, this one. Then click on go. Just you need to check this one, analysis toolpath. Just check this checkbox and click OK. Okay, right, everyone?
Can you show this in 13
Yeah, I'll show
version?
that. I'll show you the analysis toolpath. It's okay, fine, everyone. Now you can, after you click OK, then go to data tab and you will get this option. Okay, I'll show it in 2000. I have 2019, I guess. So similar, it's almost similar. Can you see my screen?
Yeah, it's visible.
Yeah. So here you need to go to file, then more, then option. Okay. Then here add-ins. So click on this analysis toolpack and then click on go and check this checkbox and click OK. Done, everyone?
Show 1 second. Show 1 second.
From beginning?
Yeah, yeah,
Yeah. Go to file,
yeah.
then more,
More. Okay, just a second. Yeah.
then go to options,
Okay.
then go to add-ins,
Add-ins. Yes.
then click on this analysis toolpack. Make it blue.
Okay.
Then click go here. Down below go button. Okay.
Yeah, I got it.
Then you'll have a pop-up window. Then you need to click on that checkbox analysis toolpack. Not
Okay.
analysis toolpack VBA, only analysis toolpack.
Okay. Okay. Got it.
Then click OK. Right?
Yeah, I got it. Thank you.
Yeah. 1 second just. Yes. So now what I'll do, I'll go to data analysis, in data tab, data analysis. I'll do the regression. Okay. So go to data analysis. Then you'll find, scroll down, you'll find regression. Okay. Click on regression, then okay. Done till here.
Yeah, done.
Now you need to, there is a pop-up window. You can find input Y range, input X range. Input Y range means Y is what? The dependent
Range of,
variable.
yeah,
Which one will be your dependent variable? Chances of admission, right?
admission.
Let the pop-up window be here in the right side. I'll select this. Like that, I'll drag this entire column. Okay. So I have till 401. Done. Now I have to select input X range. So I'll go again in the top and I'll select. We'll add header also, right? Header also will include. So I know now I have the column 401, so I'll edit it 401. Okay, so I have the labels, right? So I'll click on that checkbox. I have labels because the first row itself was the label, right? Now I want my always it's better to take your output into new worksheet. Okay, so it's already defaulted but selected. It's clear till then, clear till here.
Yeah, clear.
Yeah. Now you click OK. Yes, I got the output in a new sheet. See, it's very simple. What I was showing you initially, you are getting this similar output here. Okay. Done, everyone?
Yeah, done.
This is what regression output is in Excel. I'll show the output first in Excel as well as all the other two tools. Then we'll go to the analysis thing, interpretation thing. Okay. So this is what your Excel output. Every tool will have different types of output. Means the outlier will be different. Value will obviously be same. Okay, value will not change, but the output, the look will be different. Some suppose you are using SPSS, then you'll get some extra values. Okay, there'll be more statistics involved in regression. Okay, you'll get some extra values. Okay, so in R Studio also you'll get some extra values, or there will be some less values compared to Excel and all. Right. So which one you want first, R or SPSS? Just tell me.
R.
R.
Okay. Right. You know the code?
No.
Okay. We'll tell that. Everyone open your R Studio and your R Studio will be look like this only, right? Is it looking like this? a similar interface like me.
Just 1 minute, it's opening.
Yeah, yes, I'll wait. I understand that. So if you have installed Art Studio, in backend you need to install R also. Okay.
I am getting a four interface screen.
Yeah, I'll tell that one. So first is that this is Art Studio and this is R. So if you install Art Studio only, it will not run. Art Studio will run. The backend R will also means the R is actually the support of Art Studio. So you need to install both. After that, you need to open Art Studio only. We'll be using Art Studio. Okay. Shani, what you can do, you can present your screen because everyone will get that for window. You can present one screen. I will tell that.
Yeah, just a minute.
Yeah, you can see.
Is it visible?
It got freezed. Is it for me or? Yeah, I can see. I can see. Yeah. So we'll be using that console window. Okay, the below one. Right side, there are two windows, right?
Mm-hmm.
We need both the two windows, but in the left side, we need only the bottom one, not the above one. Okay, we'll not be using the above one.
Okay.
Okay, means you can use actually,
Mm-hmm.
but it's more user friendly, or you can say more convenient to use the below one.
What is the console part?
Yes, the console window only. So
Console.
what
Okay.
you can do, you can the above one, you can press the minimize button. There is one minimize, right?
This
Yes,
one?
yes, right. Click on that.
Hmm.
Yep. So when you want back, you can click on that double box thing. You will get it back.
Okay.
Yes. So you just can minimize or you can drag the below one little up so that
Mm-hmm.
you can see. Yes. Yeah, you can stop. Clear, everyone clear, right? We'll be using the console window actually. Yes. So after you open this console window, you're getting this some already written something. Okay. I want my screen to be clear. How do I clear it? Can anyone tell me the code? The shortcut actually, not code. Anyone? No? Press Control and L. Control and L. It will be cleared.
Yeah, got it, got it.
Done.
Yeah, done.
Control L. Okay. Now what? I have my that Excel sheet, right? This Excel sheet. You need to check whether this Excel sheet is in which format. Excel sheet can be in Excel SX format, in CSV format, all those things, right? Check the Excel sheet is in which format. So check the properties and
CSV.
properties, then you can check it where it is. Yes, the name itself says go to details. The name itself says .csv. So it's a CSV format. So I need to use the code CSV to bring the CSV file into our console or our storage. Okay, I want the CSV format code. So first I need to name my dataset. Okay, so I am naming my dataset as DF. Whatever you can name, you can name it. You can name D also. Okay, so I'm naming my dataset as DF. DF is equal to, I'm just writing the code to bring my data file into the system. So it's read.csv. Sorry, read.csv is the code to bring CSV file. Okay, read.csv. Then within parenthesis, inside the parenthesis, you need to write file dot file dot choose. Okay. Whenever you are typing something, you will get the suggestion. Okay. You just can click on this. Okay. So file dot choose, open and close parenthesis. Then I can press, I can enter comma. Then header. I had my header in the data set, right? So header equal to t. T means true. I had the header, so header equal to t. If there's no header, then I can write header equal to f. Okay. So this is what my code is. I'll press enter. You will get a pop-up window here. See, here is a pop-up window. You need to choose like how you attach the document in mail or something. Okay, just click on this. You need to go to the space. I had my dataset in desktop, so I'll go to that. I'll select my data file. So this is what admission data. Okay, just I'll press open. See here, the data has been loaded in the system. There are 400 observations and 3 variables. Okay, 3 variables mean serial number was also there, right? So that's why it's taking 3 variables. Okay, it's been loaded. Okay, now if I want to see the data, how do I see that? Okay, I'll just type df. Df is my dataset name, right? I've given the name df. So I'll write df and enter. See, this is what the data is, right? This is just to cross verify whether your data has been loaded or not. Just to cross verify, okay? Clear till here, everyone?
Yeah, I got it.
Yeah. Now what? Now before you perform any function using any operations using this data file, you need to attach the data file. Okay, there is a code attach. Okay, attach. Then you need to give the name. Within close open and close parentheses, you need to give the name of the data file you have given. Attach df. It will not return anything. It will just attach. If you don't attach means this code, if you don't write attach your data file name, you will not be able to perform any operations using the data file you have loaded. Okay, so this is compulsory. Attach thing, right? Clear, everyone, why you are doing this? Now what I will do, I'll check the summary of I'll do some basics operations first. I'll
Uh,
check.
to load the file, can we also use the file option in this program? From file, then we go to open.
You can do that, but it will be more convenient if you use code only.
Okay, okay.
Yeah.
Can you show how to copy paste this data?
Means,
Like how you brought the data from Excel file to this interface.
okay, so I have written one code now. I've given the data file
Mhm.
name.
After that, like, can you just explain once again?
Okay, you just press enter. After writing the code, press enter. You will get
Yeah,
a
yeah.
pop-up window.
Mm-hmm. I got it.
Just you need to go to that folder or that place itself where you have placed your data file.
Hmm.
Just click on the data file
Okay.
and then open.
Okay. Okay. Okay.
See, when the data file gets loaded, you'll get to see this in environment in right side. This environment window. The data file
Okay.
name you have given and how many observation and how many variables you have loaded. If it's
Mm-hmm.
showing, then that means your data file is loaded. Still, if you want to cross verify, just give your data file name and press enter. You'll get to see this,
Okay. Okay.
right? So it's fine.
Oh, excuse me, Shubhadeep.
Yeah,
Yeah, I need to leave for like I need to drop my parents somewhere.
yeah. Okay.
I'll be joining you late.
Yes.
Yeah, thank you so much.
Yeah. Now I was saying that you need to attach data file to perform any further functions or further operations. So the code is attached in bracket the data file name you have given. Okay, now we'll see some basic functions or basic operations. We want to check the summary of the data file. Summary means you will get mean, median, mode, all those things. So just type summary and your data file name is df. Df is my name. See this, the mean, first quartile, median, the what to say, the third quartile, all those things. What is quartile means? You have already know that box plot, right?
Yeah.
Yes. So this can be done from here. Okay. So there are three variables actually. Serial number, they are also taking one variable. Actually, I need to delete that uh, column. I have not deleted, so ignore that one, serial number. Okay, so chances of admission, the minimum value, the median value, the mean value, the first quartile and third quartile. The median will be the second quartile, right? Compared, if you think about the box plot.
Yes, yes.
Yes. So this is the, if you write summary, then you will get all those values. Okay. Now suppose I want to check the dimension of the data file. Okay. So dimension is dim, dim, and then my data file name df. So 400 into 3, right? 400 rows and 3 columns. It's correct only. It's very,
Correct.
yes. Okay. Now suppose I want to check the length of my data set. It's length only, length. Length. Every time you need to give the name. So length is 3. Length is 3 means there are 3 variables. Okay. Suppose I want to check the variable names in the data. So simple names df. Enter. So 3 variables, right? Serial number.
The length is the all the columns, right? The three
Yes, yes,
columns.
yes.
Okay, okay.
Names will return you the names of the variables. So serial number, chances of admission, and then GRE score. Okay. So I want to plot box plot. So box plot is simple box plot code. Box plot of any of the variable I want to go for chances of admission. See, when I start typing, you will get the suggestion. This chances of admission. I'll click this one. I don't need to type all the things. See, your graph will appear here only, right side. This is what the box plot for chances of admission. Okay, suppose now I want to have the box plot for, box plot for GRE score. I started typing GRE and then I'm getting the suggestion. I'll click this one. See this. Okay. This is the box plot for GRE score. Correct. Suppose now I want to check the histogram. Okay, histogram is hist code, right? Histogram for all the 2 variables. Histogram of, hist, then chances of admission. This is the histogram, right? What type of skewness is this? It's a positive skewness or negative skewness?
Positive.
No. The data is what to say? The data is more in your right hand side, right? If you draw the curve, how it will be? It will be tilted towards your right hand side. So
Yes,
your
yes.
right hand side means a negatively skewed. Okay. It's a negatively skewed. Okay. Next, suppose I want to check histogram for GRE score. I can what? Still, this is also negatively skewed, but I can say it's better than the chances of admission. The normality is better than the chances of admission. Okay. So now can you see, like I have drawn actually 4 plots, 2 box plot and 2 histogram. It is showing one at a time, right? I want all the plot in a single window. Okay, that will be more convenient, right? If I can see 2 box plot and 2 histogram in a single window, that will be more good. How I can do that? How I can do that? Anyone knows that? Okay, before that, what I'll do, I'll draw the this probability plot. Okay, the histogram has been drawn. Now I'll draw the normality plot. Sorry, not probability, normality plot. That graph. Okay. So how I'll do that? See, this is the frequency, right? ZRD score, and this is frequency. To draw that Bell-shaped curve, I need to change it to density. Okay, this frequency needs to be changed to density. Okay, so what I'll do, I'll type histogram, then suppose GRE score, then in comma you need to write FREQ. FREQ will identify frequency. FREQ is equal to false. False means it will automatically change to density. See this change to density, right? Now I want to draw lines. Okay, so the code will be lines, then the variable name, sorry, uh, lines, then density, in bracket the variable name. Okay, say this. You want this, right? The bell shape card.
Yeah, got it.
This is what, yeah. This is how I can get the bell shape curve. Looking the histogram, I can't say, right, whether it's a right positively skewed or negatively skewed. If you draw this bell shape curve, then only you can say perfectly that it's a positively skewed or negatively skewed. Okay.
Can I ask one question?
Yeah, sure.
Like, if the skewness is towards the right hand side, then it will be positively skewed, no?
Yes.
So this one is like, it is in the middle one. Yeah, okay, I got it.
Yeah. So this is how I can draw. Now I was still talking about how I can present all my 4 graphs, 2 histogram and 2 bar graph, in a single window. So for that you need to write par. There is a code par. Okay, par, then mf row equal to c in bracket 2 comma 2. This will define in the plot itself. You'll get a matrix type 2 comma 2. So 2 rows and 2 columns. You can write 3 comma 3 also. You can present 3 graphs at a time. Sorry, 6 graphs at a time then. Okay, so I'll change this one, right? Now I want to repeat all those things. So I'll just copy it. I'll not type again. So I'll copy it and I'll paste it. I've changed my format. It will be next time if I want to draw any graph, it will be coming as 2 comma 2 format. See this. Okay. Now I'll draw this box plot again. Just copy and pasting it. Code will be similar. Okay. So histogram for chances of admission. Then histogram for GRE score. See. This is more convenient, right? I can see 4 graphs at a time. Is it not looking good?
This PAR stands for?
It stands for what? I don't know. This is the code.
PAR bracket MFROW.
MF row. Yeah.
MF row. Okay.
Equal to C in bracket 2 comma 2. So it's 2 comma 2.
Okay.
Okay. If you want to get back to the previous format, 1 graph at a time, then you need to write again this code par MF row. I don't want it 2 comma 2 formats. I'll make it 1 comma 1. So 1 graph at a time. Okay, from next time onwards, if you draw any graph, it will be as 1 comma 1. Right. Suppose now, why I am showing all those graphs and all, because these all are interconnected with regression, right? The box plot, you can see whether there is outlier. See, there is outlier in this. Can you see this? There is a dot. There is outlier. Okay. So here you can see the bell-shaped curve. So all those histogram, box plot, all are interconnected with regression. Next, another one is the scatter plot. The scatter plot is the graphical representation of simple linear regression. Okay, so scatter plot, how do we do that? So it's simple code, plot and then the variable you want to consider. You need to give the variable name. So plot x comma y, right? How do you draw the plot? X comma y. So x is your dependent variable or independent variable. Which one is your dependent variable?
X. X.
X.
X is
X is the
GRE score.
X is
independent.
independent. Na?
Independent.
Hmm.
So first you need to give your independent variable name. Independent variable which one? GRE score, right?
GRE.
So GRE score, comma, chance of admission. Just press enter. See, this is what the scatter plot is.
Scatter plot.
Yes. So after you see the scatter plot, can you identify what type of relation it is? Is positive relation or negative relation between these two variables? So for that, you can identify from this scatter plot itself. But it's better to draw a line in between the scatter plot. Then only you can easily identify or easily say that there is a positive relation or negative relation. So to draw a line in the scatter plot, I'll write a code AB line. AB line, then LM for linear model. Okay. This time you need to do it in reverse. Y comma X. So we need to write chances of admission first, LM in brackets, so chances of admission, comma, GRE score. Okay. 1 second. Sorry, yeah. So it's not comma actually. I understand the mistake. It's not comma. Can you see just below your escape button, there is one sign tilt
That curve
below
sign,
your
right?
escape button.
That curved sign, right?
Yes, this one. It's
Mhm.
called a tilde symbol. So you can, in between these two variables, you need to put this tilde symbol and then press enter. See, you will get that line. Okay. Can you identify
What is
now?
the code?
Sorry,
The Please repeat the code once.
AB line, ABLINE
Hmm.
in
Then
bracket LM for linear model.
LM. Okay,
Yes,
model. Hmm.
yeah. Then in bracket your what is it? Your Y variable.
Chance of admission.
Yeah, chance of
Hmm.
admission. Then the tilde symbol. It's just below your escape button. Shift and that button. With a tilde symbol. Then your X variable.
That is GRE one.
Yes.
GRE score.
Just press enter. You will get this one. Now can you identify which type of relation it is between these two variables? A positive relation or negative relation?
Yeah.
It's a
Okay.
positive. It's a positive relation, right? One is increasing, GRE score is increasing, and another one also increasing. The slope is in positive side, right?
Yes.
So it's a positive relation between these two variables. Means if
Uh,
GRE score increase, then this will also increase. Chance of admission will also increase.
yeah. When we use plot, is the scatter plot a default
Yes,
graph?
default one.
Okay, okay.
Yeah. Now I want to check the correlation. So uh, now graphically I was telling that this is a positive correlation or positive relation I was talking, right? So now I want to check the value of correlation. So correlation value lies between -1 to +1. Okay.
Hmm.
So
Yeah.
0 means there is no relation.
Hmm.
-1 means highly negatively correlated.
Hmm.
+1 means highly positively
Positive.
correlated.
Hmm.
So now I want to check whether how much is the correlation value here. So for that I'll write COR. The code is COR. Then your X variable. Okay. Then comma your Y variable. Yeah. Can you see that correlation value is 0.8026, almost zero point 0.8, or means almost nearer to 1, right? So I can say it's almost like highly positively correlated, these two variables. Clear everyone till now?
Yeah. Clear.
Yes. Now simple linear regression is very simple. So simple linear regression, I'll give my model name SLR, simple linear regression model. This is similar to the name I have given for my dataset. So for this model, I'm giving the name SLR model. SLR model equal to, now I'll write my formula. So it's LM, linear model. Then what? My Y variable, chances of admission. Okay. Then this again, this tilt symbol. Then my X variable, GRE score. Enter. Will not get any output here. Not get any output. To get the output, you need to write summary. Then the model name you have given, SLR model. Okay. Then enter. See, this is what your output is. Regression output. What I'll do, I'll copy this thing and I'll paste it in Excel. Till now, everyone clear? Clear?
Yeah,
You're
clear.
done?
Yeah.
Yes. I'll copy it just beside this one. See this. Yeah. See this, the intercept value minus 2.4360. Is it matching?
The match.
2.4360 and 0.009975. It's matching, right? Okay, this is what the coefficient table is. So this was what our coefficient table. Okay. Right. See your multiple R value. Multiple R square value is 0.6442. 6441 is like there are more than four decimal points, so that's what it's coming like this. Almost the value is matching, right? This is what the output is in R Studio. Clear, everyone? Till here? Are you done? I'll share this code actually. You want this code, right?
Yeah.
I'll share this in a notepad. I'll share this one. You can practice.
Okay.
Yes. Now I'll check with SPSS. You all have installed SPSS, right?
But as we saw that while making all these calculations in R, it takes a lot of time. But in Excel, we can just go forward with the data analysis and regression.
No. You just need to do this. I was just explaining all those things. The conceptual part. You don't need to do all those things, no?
So using only these two formulas, we can get everything.
Yes. Using these two formulas, you will get this output. You are actually interested for this output only. Yes. So I was just explaining all those concepts, the concepts behind regression.
Okay.
Yeah. You need to know that actually. This is like the concept is actually very important for your interview purpose. Everyone can do this, right? If someone is mug upping this code, can easily run this regression. Why we are doing this? That's more important. Okay. Now I'll go to data SPSS. Everyone has installed SPSS. Everyone has installed.
No, this is not installed.
Okay. Sign you.
I have installed, but I think this is a different one.
Okay, I had shared one link. Notepad, there was one link. You can check that, and you can. There is a drive link actually. Okay, just install that one. This is a what to say. This is a
IBS, SPS, IBM. Yeah. I have installed this one only.
yeah. I'll just show it. SPSS will take only 2 seconds to do that. Just you can remember the steps. So first you need to import the file. Okay, so file, then import data. You already know there are different types. So my data type was in CSV format. Okay, so I'll just click on this and click open. Okay, this is what my data. So you need to check whether your first line contains the variable name. It's already checked, so I'll just press OK. I'll not change anything. Okay, so it will open. Take some time, obviously. Software is heavy. Yeah, there are actually two windows. When you open SPSS, there will be actually two windows. One will be kind of Excel type, right? You can see Excel type. One will be blank page. Okay, this blank page is actually the output window. You can see this. This is output window. Whenever you are doing any analysis, your output will be in this window only. Data is imported or not? What happened? Okay, I need to close it. Yes, till then, let me explain what is. You are getting those values, right? R square, adjusted R square. Okay, so can see correlation. I was talking about correlation, right? So if you want to write the interpretation, you can write. In correlation, this helps to identify the relationship between the independent and dependent variable. Okay. Are you writing the concept?
Yeah, I am writing.
Yes. So correlation value actually helps to identify the relation between dependent and independent variable. The correlation value lies between -1 to +1. So if the value is -1, then we can say it's highly negatively correlated. If the value is 0, then there is no relation. And if the value is +1, then it is highly positively correlated between the dependent and the independent variable. Okay, now I know why it is not opening. My Excel sheet is also open, that's why. I'll close it. Okay, done correlation.
Yeah, noted. I have written.
Yes. So you are seeing these values, right? Multiple R.
Do we need to close the Excel sheet?
Yes, Excel sheet. If you open the Excel sheet and also SPSS, you're trying to import, it will not be getting imported.
Okay.
Okay. You see this R square value, right? What is the meaning of this R square? R square value shows the goodness of it. How good is the fit is? How good is the model actually? Yes. Now see. So actually. Is just wait. I'll come to that point actually. So we'll do that analysis now. You can see here there is one data view and one is variable view. Okay, so in variable view we'll see all the variable details, right? So I'll just delete this variable. I'll just select it, enter row and then delete. Okay, now I go to data view. I have only two variable admission and This one. So to perform regression, you need to go to Analyze tab. Here Analyze, then go to Regression. Then it's linear, right? Simple linear regression or multiple linear regression. So linear regression. Now see here, there is a dependent variable list and independent variable list. Which one is the dependent variable? Chances of admission. So I'll click on this and do this one. It will come here. This GRS code is independent variable, so I'll bring it to here. Now you can go to statistics. You want anything? Yes, I want this Darwin Watson. Are you familiar with this term, Darwin Watson?
No.
Okay, then I'll ignore this. And in plot, you can do histogram plot. Histogram, you're familiar, right? You're in bell-shaped curve and all.
Mm-hmm.
Yes, we'll get that one here. Here will not be, I don't think you'll be familiar with all those things right now. I'll not be changing anything here. I'll press OK. See, you will get all these output in the another window. See this. This is what your model summary, R square, whatever I was talking about. This one. This one is the first table, R square, adjusted R square. Then this ANOVA table and this coefficient table. These three are actually important here. Remaining all you can ignore. This one you can ignore. Okay, and this is the bell-shaped curve for regression. Okay. Right?
Can you repeat the whole step after importing?
After importing, you need to go to Analyze.
Analyze, okay.
Then Regression.
Okay.
Then Linear. Click on Linear.
Yeah, I have done.
And then
Dependent and independent. Okay.
Yes. Now go to plot, only plot.
So in the dependent column, I need to select the whole column.
No, independent. Like that I have to do. Initially it will be like this, right? Blank
Yes.
everything. So dependent variable, which one is dependent variable? These two are the variables you have in the data. Chances of admission is my dependent variable. I'll click on this and click this arrow.
Oh,
Dependent variable.
okay.
To bring this independent variable here, I'll click on this and click here. Now go to plot and only check this histogram and continue. Then click OK. Done?
What was the interpretation of correlation at 0?
Correlation at 0. Acha, correlation 0 means there is no relation between the two variables.
Okay.
Suppose
And
I'm saying one example is that you're getting of marks in NCP and your food consumption. This example I was giving in the last session. How much food or how many times you are eating food in a day, will that be dependent on your marks?
No.
Or sorry, your marks, will that be dependent on your how many times you are eating? Definitely
No.
not. So there is no relation between these two variables. This type.
So at 0 there is no relation.
Yes.
And at 1 the relation is highly positive.
Yeah,
And at
highly positive and highly negative.
At -1 it's highly negative.
Yep. Okay, so this is what the output is. These three were actually interested. Okay. Model summary, ANOVA table, and coefficient table, and the histogram plot if you want to see. Right. Now you need to know the interpretation. What is R square? Anyone, what is R square? I hope you have already have.
Yeah, we have done it in the class, BA
Yes.
class.
So R square is the R square you can write actually. The interpretation is very important. R square value shows the goodness of fit. First point. R square value shows the goodness of fit. R square value lies between 0 to 1. Okay. So suppose your one example I'm giving you. Suppose your R square value is 0.6. Okay, 0.6. So that means it signifies your dependent variable is 60% in association with your independent variable. There should be some association rule, right, in between the dependent and independent variable. So if your R square value is 0.6, that means if I multiply it with 100, it will be 60, right? So that means your dependent variable is 60% in association with your independent variable. You can write the example so that you will in next time if they are giving some value in the MCQ. R square value is this. What is the significance of this? If they ask you to write something, so R square value is 0.6 means the dependent variable is 60% in association with your independent variable. Clear?
Yeah, clear.
Next point, R square value can increase if we add extra independent variable. So you can see here I have only one independent variable, right? So your R square value is 0.644. Okay. The point was that R square value can only increase if we add extra independent variable. Okay. If we add one more variable, it will be multiple linear regression, right? In multiple linear regression, there will be more than one independent variable. Okay. Suppose here the variable was GRE score. Then what? Suppose another variable is your study time.
Ours,
Study hours. Okay, if you are studying more, then you will be getting more marks. Okay, so if I add this variable to your study time, then your R square value will increase. Okay, right. Suppose I am giving you another variable. Again, take the same variable, your food consumption time. So time of food consumption in a day. If I add that variable, will R square value will R square value change?
no.
No, it will not change. So your R square value actually decrease that time. If you add extra variable, if that variable is not having impact on the model, then your R square value will change. Change means it will decrease. If R square value is getting decreased, then that means you can eliminate that variable. So you need to eliminate that variable food consumption, number of food consumption in a day, number of times food consumption in a day. Okay, clear this concept?
Yeah, clear.
If the variable is not having impact on the model, your R square value will decrease. R square value decrease means that signifies that you need to eliminate that extra independent variable you have added in the model. Clear? Next is your adjusted R square. This one, adjusted R square. For adjusted R square, the first point is adjusted R square is a measure of adjusted R square for a number of independent variable in the regression model. So it will just what to say, if the R square value and the adjusted R square value is the difference is less. See here the value is 0.644 and 0.643. The difference is very less, right? That means the variable we have taken into consideration is good for the model. Okay, concept is clear.
Can you please repeat this adjusted R square?
If the R square value and adjusted R square value, the difference is less, then whatever variable we have taken into consideration for regression, that's actually good.
Okay.
Best fitted for the model, you can say. Variables are best fitted for the model. Okay. Similarly, after adding independent variable, if the adjusted R square value is decreasing, that means we can eliminate that. If the adjusted R square value is increasing, then we can add that variable too.
So our R squared value will remain constant whether we are adding two or more independent variables.
Sorry.
The value of our R square will remain constant if we are adding two or more independent variables. Then
No, no,
the
no.
value of adjusted R square will change.
Both will be changed.
Both will be okay.
Yes. It will increase only if we add extra independent variable and that variable is having impact in the model. If it's not having any impact, then it will decrease. If it's decreasing, then that means we can eliminate that variable. If the value is increasing, that means we can add that variable too in the model.
So if it is a good, I mean, if it is good to fit, then the difference will decrease between R square and adjusted R square.
Yes,
Okay.
yes, that's it. The coefficient table actually, this is the what? B naught value, the constant B naught value, and this is the B1 value. Okay, copy this. Yeah, this is the B naught value and this is B1 value. Now you can write equation, right? Equation you can write y cap. Okay, y cap is equal to minus 2.436 what
plus B1
plus 0.010 into GRE score.
GR square.
This is what the regression equation is. Okay. The standard error. How do we calculate the standard error? You have that formula. B by
y
SB.
minus y hat whole square divided by n minus 2 root over.
Uh-huh. Repeat.
It was root over y minus y hat whole square divided by n minus 2.
No. The standard error will be
SSC by
calculated in
n minus
formula
2.
in formula only. So standard error will be calculated using this one. These statistics will be calculated by B1 by SB1. So B is the coefficient. Okay. See, B is the coefficient and SB is the standard error. Okay. So in this particular table, you'll be given the missing value. Suppose these two values are given and this is missing. How do you identify that? I've given the formula. T is equal to B1 by SB1. So B by SB, okay, right? So T statistics is T. So just do it if you have calculator. B by SB. So minus 2.43 divided by 0.117. You'll get this value. Okay, right. Getting this? Getting this value? Please, I'll do that.
Yeah, got it.
Yes. Similarly, this one by this one, you will get this one. So in suppose next problem, this value and this value is given. Problem 3 here. This value and this value is given. You need to identify this one. So you already know the formula. T stat is equal to B by SB. So this is B. So T stat into SB. So this into this you will get this value. Okay. Similarly, in different way, you will be getting the missing value from problem. So one more thing is that, yeah. So in ANOVA table also you'll be given the missing value. You know this SSR, SSC, SST, all those formulas. Remember all those formulas. That will help you to identify the missing value. Okay. This exercise is actually very helpful. It's there in the drive. You can check. All those problems, all those missing values identification is given. Right. That's it for simple linear regression. There's nothing actually. So we'll go next session. We'll go for multiple linear regression. Any doubt till here?
No, not from my side.
Yes. So if you are interested, we can do that. Not simple linear regression, there is nothing. So in multiple linear regression, we can do in SPSS, R, in Excel also, as well as if you want in Python. How many of you know Python? Do you know Python? Olivia.
I know the basics. I have done a course
Okay.
online.
If you know Python,
Multiple regression, there are more than one dependent variables.
yes,
Okay. That's the basic difference between single and multiple regression.
yes. So
Okay,
you can
okay.
add one more variable, right? GRE score and your study time.
Yeah, okay.
One more variable also you can add.
So we can take this example itself from the next class.
No, we'll have it another example or
Okay.
another data set.
Okay. And also I saw that you also had Power BI in your